Hey everyone, and welcome. If you're a developer, you already know that writing code is one thing. But writing good code, code that's flexible, scalable, and actually easy to maintain, well, that's a whole other ballgame. Today, we're going to demystify one of the most powerful concepts in any programmer's arsenal, design patterns. So let's just dive right in. I bet this sounds familiar, right? You kick off a project with this huge burst of energy. But as it gets bigger, things get complicated. New features are just kind of bolted on, dependencies get all tangled up, and then boom, you suddenly realize you're lost inside a massive structure that you built with no clear plan at all. And this leads us right to our first big point, the absolute chaos of code that can happen when we try to build without a plan. Yeah, that skyscraper you built without blueprints, it's not just messy, it's genuinely dangerous. A tiny change in one little corner of the code can cause a total collapse somewhere else. The whole thing becomes fragile, a real pain to change, and a total nightmare for anyone new trying to join the team. This, right here, is the exact problem design patterns were invented to solve. So how do we get out of this mess? Well, the good news is, you're not the first person to deal with this, not by a long shot. Turns out, generations of programmers before us ran into these exact same problems. And luckily for us, they left behind the blueprints. This slide really just nails it. You've got to think of design patterns not as these strict, rigid rules, but as a toolkit. They are tried and true, reliable solutions to problems that pop up over and over again in software design. Honestly, they're the professional-grade tools that separate the hobbyist from the master architect. Now, this toolkit, it's actually pretty well organized. Even though there are hundreds of patterns out there, they generally get grouped into three main categories, all based on what they help you get done. Okay, let's open the first drawer in our toolbox. Patterns that are all about creating things. How do you actually manufacture the bricks and the beams and the windows for your skyscraper in a way that's smart and flexible? These are your creational patterns. And put simply, they just give you better ways to create objects, which seriously boosts flexibility and lets you reuse code. Think of them as the factory floor and the power tools for your project. They let you pump out the components you need without having to hard code every single tiny detail. Okay, here's a classic problem. Imagine you need a single object to manage something critical, like a database connection or your app's settings. If you had multiple instances of this mission control floating around, it would be total chaos, right? So, how do you make sure you only ever have one?
In the answer, it's a creational pattern called the Singleton. It's this really elegant solution that guarantees two things. One, a class can only ever have a single instance. And two, it gives you one global way to get to it. Problem solved.
All right, so you've created all your objects. Now what? Let's move on to the next category and see how we assemble those components into a structure that's stable and actually makes sense. And that is the job of structural patterns. As you can see, they're all about putting objects and classes together into bigger structures, all while keeping everything flexible and efficient. These are literally your architectural blueprints, showing how all the different parts should connect and work together. Here is a super common structural problem. You've got this awesome new component you want to use, maybe from a third-party library, but its interface, its plug, doesn't match the socket in your system. It's just like having a European plug and trying to jam it into an American wall outlet. It's just not going to work. So what do? Well, the solution isn't to rewrite your whole system or mess with the new component. Instead, you use an adapter pattern. Its purpose is so simple and clear. It lets objects with totally incompatible interfaces work together. It's basically the universal travel adapter for your code. And here's a super simple breakdown of how it works. You've got your two incompatible parts, right? They can't talk to each other directly. So the adapter just sits in the middle, acting like a bridge or a translator, taking requests from one and making them understandable to the other. And just like that, they can collaborate seamlessly. All right, awesome. Your skyscraper is built, it's structurally sound. But now what? How do all the systems inside it actually talk to each other? How does the elevator know someone on the 10th floor pushed a button? How does the fire alarm tell the sprinkler system to turn on? Well, that brings us to our final category, behavioral patterns. You can think of these as the communication systems for your software. They're not really about structure. They're all about how objects interact and delegate responsibilities to get work done effectively. So, think about this challenge. You've got one central object. Let's say it's a user's account profile.
When that profile changes, a bunch of other parts of your app, like the nav bar, the settings page, the little welcome message, they all need to be updated. How do you handle all those notifications without your code becoming a tangled mess of direct calls?
The solution is the observer pattern. What it does is create this really clean subscription model. Other objects can subscribe to that central profile object. Then, whenever that profile changes, it automatically notifies all of its subscribers without even needing to know who or what they are. It's just a clean one-to-many communication channel. So let's just pull this all together real quick. Creational patterns, they're your factory and power tools for making objects. Structural patterns, those are your blueprints for putting them all together. And behavioral patterns, they're the communication systems that make everything interact. That framework, right there, is your key to understanding this whole toolkit. So now that we have the toolkit and we have the blueprints, what does this all actually mean for you as a developer day to day? Why is this stuff so important? Because at the end of the day, design patterns are so much more than just clever coding tricks. They're a shared vocabulary. When you say, hey, let's use an adopter here, or you know what, this should probably be a singleton, every other developer on your team instantly gets it. They understand the structure, the intention, and the trade-offs. It just leads to smarter collaboration and code that anyone can actually maintain. By understanding these patterns, you're not just coding anymore. You're engineering. You're building robust, elegant structures that are designed to stand the test of time. So really, the only question left is, which blueprint are you going to use first?